Hi, welcome again to another edition of Chrysler's Current Service Information. Today's program will be a little different. In the past, we've generally concentrated on a single topic. Today, though, we've got no less than 5 different things to talk about. 1. The soldered-in odometer chips on new Huntsville clusters. 2. A revised hotline newsletter. 3. The subject of inadequate body grounds on rear-wheel drive B vans and the problems they can cause. 4. Another ghostly condition called radio frequency interference. And 5. Catching faulty diodes in the fan relay circuit. Since all these topics are related to electrical or electronic components, today's program is called Electrivial Pursuit. And now on to the first topic. Soldered-in odometer chips. Here we have a Huntsville-built electronic instrument cluster, and here is its odometer chip. Up until mid-1986, whenever this chip malfunctioned, you simply took it out and replaced it with a new one. However, since mid-1986, Huntsville has been soldering the odometer chip right onto the circuit board to improve the reliability and reduce odometer chip problems. Note that on the newer Huntsville clusters, there is no odometer chip chimney. That means the chip is soldered directly onto the circuit board and cannot be removed. To service these chips, the entire cluster must be removed and sent to the repair center. Furthermore, replacement chips will no longer be available for Huntsville clusters, meaning that Huntsville electronic clusters built before mid-1986 must be sent to the repair center for exchange and upgrade to the new soldered-in odometer chip. So remember, you cannot replace odometer chips any longer on Huntsville-built electronic instrument clusters. Next, topic number 2, revised hotline newsletter. Recently, you received a hotline newsletter, HL 2986, dated July 21st. It talked about the replacement of odometer chips in electronic instrument clusters produced by Motorola. However, as you probably know, the odometer chips in Motorola clusters are permanently soldered in. You can't remove them or replace them. To correct this error, we've published a revised newsletter, HL 2986 Revision A. It's dated August 11th. It directs you to replace the entire cluster to solve odometer malfunctions. The procedure for resetting the mileage on the chip in the new cluster should be followed as written. Coming up, topic 3, inadequate grounds on rear-wheel drive B vans. Lately, we've been receiving reports of abnormally high temperature readings on rear-wheel drive B vans. It's important to note that if you run into this condition, you need to make sure the engine is not overheating. If it is not, this condition may be a symptom of a different problem, inadequate grounds. On rear-wheel drive B vans with a 114 amp alternator, the cause of the high temperature reading is an inadequate alternator ground, battery, or frame rail ground. This causes an increased magnetic field to be induced around the alternator output wire. The alternator current then seeks another ground by branching off at the bulkhead to the body ground at the driver's side and the battery ground at the bulkhead. Since the temperature gauge also grounds indirectly through this battery ground, its reading is affected by the spillover from the inadequate ground. Another symptom you may note, besides the high temperature reading, is an intermittent drivability problem, especially during periods of high current draw. So if you see a rear-wheel drive B van with a 114 amp alternator, an intermittent drive problem, and an unexplained high temperature reading, you can suspect an inadequate alternator ground. A TSB showing you how to correct this condition will be released shortly. Now on rear-wheel drive B vans with 78 amp alternators, you'll find exactly the same symptom, an inadequate ground. However, as you know, the 78 amp alternator grounds at the engine mounting bracket. Then the engine grounds to the battery through a ground wire and the battery ground to the bulkhead. This ground can be inadequate because the screw which attaches the ground wire to the bulkhead has not cut through the bulkhead sealant to make good contact with the metal. The screw should have a special notch at the bottom to cut through the bulkhead sealant. If you find any other screw, clean the sealant out of the mounting hole, and be sure to clean the area under the ground eye before you reinstall the ground wire. It's critical to check this ground with an ohm meter, because if this ground is inadequate, the alternator will ground through the transmission governor support. If that goes on long enough, your customer will come in with not only an abnormally high temperature gauge reading, but also with a ruined transmission. And if all you do is service the transmission, you will not have solved the real problem, an inadequate ground. The key to preventing both these conditions is to check the temperature gauge during new vehicle prep. If the gauge reads high, follow the shop manual procedure to check the actual engine temperature. If it's normal, simply check the alternator ground and, if necessary, make the appropriate repair. Next, subject 4, radio frequency interference. On vehicles with intermittent wipers and an external voltage regulator, you may run into a condition where the wipers stop or skip across the windshield when used in the intermittent mode. The cause is called radio frequency interference, emitted by the voltage regulator. As the voltage regulator does its job, it emits a wave-like electromagnetic signal. When this signal reaches the sensitive microcircuitry controlling the intermittent wipe function, the frequency causes these circuits to forget what they're supposed to do. So as these waves blank out the circuitry controlling the intermittent wipe function, the wipers stop and start right in the middle of a cycle. Consequently, they seem to skip or chatter across the windshield glass. To diagnose this problem, simply unplug the voltage regulator. If the intermittent wipers then work, you know radio frequency interference is the problem. If unplugging the regulator does not correct the condition, look for a ground problem in the wiper motor park switch circuit. If the problem is the regulator, replace it. It has been improved so that its radio frequency emissions won't interfere with the operation of the intermittent wipers. Next, the final subject and the last word. Faulty diode in fan relay circuit. Our final subject today has to do with faulty or missing diodes in the fan relay circuit. This will cause engine overheating or repeated blowing of the number 2 fuse. It's number 10 on the H car and number 6 on the P car. Early 85 vehicles had a diode jumper installed at the relay. On late 85, 86, and 87 vehicles, the diode is installed in the transmission wiring harness. To help you diagnose this problem, Service Engineering has published a hotline newsletter, number HL 3286, dated August 11th. Basically, it tells you this. On early 85 cars, the diode is in the jumper harness plugged into the fan relay. If it's open or missing, the engine may overheat. On late 85 through 87 cars, the diode is in the transmission harness. The 86 and 87 wiring diagrams will tell you where. By the way, look for it in the starter system wiring diagram instead of the coolant fan wiring diagram. If the diode is open or disconnected here, the engine may overheat. If the diode is shorted, the number 2 fuse, it's number 10 on the H car and number 6 on the P car, will blow repeatedly when the ignition is turned on. Follow cooling system diagnostic procedures to correct the overheating condition. If they tell you to replace the logic module, make sure the diode is in place and is not open before you replace it. If the number 2 cavity fuse keeps blowing when you turn the ignition on, disconnect the diode wire for diagnosis. If the fuse doesn't blow then, the diode is shorted and must be removed from this location in the harness by cutting it out and taping back the wire. Whether the diode is open or shorted on 1985, 86, or 87 models, install the field service jumper harness with diode at the relay, part number 4331613. And that's the final word. But before we go, let's review what we've learned today. First, you can no longer replace the odometer chips on Huntsville clusters. Second, there is a revised hotline newsletter which tells you must replace a Motorola electronic cluster if the odometer chip fails. Third, unexplained high temperature readings on rear-wheel drive B vans may be caused by an inadequate alternator ground. Fourth, on vehicles with intermittent wipers and an external voltage regulator, radio frequency interference may cause the wipers to skip across the windshield when in the intermittent mode. And fifth, faulty diodes in the fan relay circuit may cause engine overheating or repeated blowing of a fuse. Obviously, we've had to skim all these subjects very quickly, so be sure to check out all the published hotline newsletters and TSBs for more details. Also, in a future program, we'll talk more about radio frequency interference and a related condition, electromotive induction. Both can cause ghostly problems like those skipping wipers. The only difference is that radio frequency interference is airborne, while electromotive induction is wire-transmitted interference. And that is the last word. Thanks for working with me. See you next time on Chrysler's Current Service Information.
The customer satisfaction notification detailed in this program pertains to 1986 Dodge Daytona and Chrysler Laser cars equipped with a T-bar roof. The service procedure for these vehicles involves the replacement of both the right and left side door outer belt moldings. The present moldings are made of an incorrect plastic material which tends to warp at temperatures experienced in warm climate areas, resulting in a poor appearance along the sides of the molding. For service of affected vehicles, door outer molding packages, part number C3940287, will be provided free of charge to all involved dealers. This package includes both the right and left door moldings. In addition, replacement decals to be applied to the moldings after they are installed are being mailed to all involved vehicle owners known to Chrysler. The owners are being asked to take the decals to their dealers at the time of service. If needed, additional decals may be ordered at dealer cost from parts depots by using the appropriate service part number. One of 4 different decals should be used depending on the car lines and options. These decals are the same as those applied to each car at the time of manufacture. For all 2.2-liter or 2.5-liter EFI non-turbo lasers and Daytonas, a red electronic fuel injection decal, part number 4328814, should be used. Use a white turbo decal, part number 4328815, for 2.2-liter turbo lasers and Daytonas, except Turbo Z. Use a red Turbo Z decal, part number T668CR1, for all Daytona Turbo Zs, except for black Zs equipped with the Carroll Shelby handling package. Use the gold Turbo Z decal, part number T668EY1, only on black Zs equipped with the handling package. To begin the service procedure, for each door, remove the front and rear door frame seals, and then remove the inner door belt molding cover. Next, follow the correct service manual procedures to remove the door trim panel, and then remove the air-water shield. After removing the air-water shield, mark the position of the 2 glass stabilizers. Then loosen the 2 stabilizer bolts. With the glass lowered so that the attaching nuts are visible through the lower access hole, mark the exact location of all 3 attaching nuts with spray paint. The accurate marking of these nuts is critical in order to ensure that the glass is later reinstalled in exactly the same location to eliminate the possibility of water or air leaks from a mispositioned glass. After marking their positions, remove the 3 glass attaching nuts and then carefully raise the glass. Hold the top of the glass to stabilize it during this step. To remove the glass, first tilt the glass inward at the top to disengage it from the lift plate retaining studs. Now, lower the glass lift plate approximately 2 inches. This distance is critical for glass removal. Then pull the glass upward out of the front lift plate retaining bracket and up through the door top opening. Next, remove the door belt molding. To accomplish this, First, remove the 7 molding to door panel screws and remove the belt weather strip. At the front of the door, remove the 2 front molding bracket screws. Now, pry upward on the rear of the door molding with a fiber trim stick to release the anchoring tab. With the door closed, pull straight out on the front of the molding to disengage the Christmas tree fastener and remove the molding. After removing the molding, remove the Christmas tree fastener from the door with needle nose pliers and discard it. You may observe that some vehicles have 2-sided tape attaching the molding to the door. In this case, clean the tape residue from the door surface after removing the molding. Replacement of this tape will not be required with the new molding. Next, transfer the front molding bracket from the old molding to the replacement molding. Now begin the reassembly procedure using the new molding in the reverse order of the disassembly. When installing the new molding, make sure that you engage the molding anchor tab at the rear of the door. With the door closed, align the front of the molding with the front edge of the door. Then push the Christmas tree fastener through the hole in the door. From inside the door, pull the Christmas tree fastener with needle nose pliers until the molding fits tightly against the door surface. For ease of molding to door installation, pre-align all 7 molding J-clips with a scratch-awl prior to installing the attachment screws. When installing the glass, bottom the glass lift plate and then raise it approximately 2 inches. Install the glass by first inserting the lower front edge into the front retaining bracket of the lift plate. You may have to move the lift plate bracket slightly in order to align the slot with the glass. After seating the glass in the bracket, carefully roll the glass into position to align the 3 glass attachment studs with their corresponding holes. Be careful during this step to not allow the front edge of the glass to slip from its seated position in the bracket slot. After engaging the 3 glass attachment studs, be sure to align the glass exactly with the spray-painted attachment markings, and then torque the 3 attaching nuts to 65 inch-pounds.
Align and tighten the glass stabilizers to 115 inch-pounds. Then follow the service manual procedures to reinstall the remaining trim parts.
Next, apply the supply decal to the rear of the molding by using the decal on the other door molding as a guide to properly locate the decal. Finally, water test the repair to ensure that no leaks are present and clean the glass to complete the service procedure. Dealers are urged to service any involved stock vehicles before retail delivery and to contact buyers who are not identified on the vehicle list to schedule this service without delay. For further information regarding vehicle lists, owners of affected vehicles, parts allowances, and service procedures, refer to the Dealer Customer Satisfaction Notification number 391 of December 1986.